I'm Vanilla. In today's video, let's solve problems using Kirchhoff's current law. I'll start with a quick overview of Kirchhoff's current law, KCL. According to KCL, the sum of currents entering a node equals the sum of currents leaving the node. I've explained this law in detail in my last video. Please check that out. In this video, we'll solve 3 problems based on KCL. How about beginning with a simple problem? In the given circuit, find the current I1. Consider this node. The current entering this node is 1.5 amps. The current leaving this nodes are I1 and 0.5 amps. According to KCL, 1.5 is equal to I1 plus 0.5. Therefore, the current I1 is 1 amp. I hope this is all clear now. Let's move on to our next problem. In the given circuit, find the currents I1, I2, I3 and I4 as well as the resistance R. This is a parallel circuit. In a parallel circuit, the voltage is the same across all components. So, the voltage across the 120 ohm resistor is 24 volt. According to Ohm's law, I is V divided by R. Therefore, I1 is equal to 24 divided by 120, which equals 0.2 amps. Similarly, the voltage across 240 ohm resistor is 24 volt. Hence, I2 is equal to 24 divided by 240, which equals 0.1 amps. Likewise, the voltage across the 48 ohm resistor is 24 volt. So, I3 is equal to 24 divided by 48, which equals 0.5 amps. Now that we know I1, I2 and I3, we can apply Kirchhoff's current law, KCL, at this node to find I4. The incoming current is I and the outgoing currents are I1, I2, I3 and I4. So, I is equal to I1 plus I2 plus I3 plus I4. Substituting the known values, 1 is equal to 0.2 plus 0.1 plus 0.5 plus I4, which gives I4 is equal to 0.2 amps. Finally, to find the resistance R, note that the voltage across R is 24 volt. Using Ohm's law, R is equal to V divided by I. So, R is equal to 24 divided by 0.2, which equals 120 ohm. If you have any doubts, let me know in the comment section below. Let's move on to our final problem. In the circuit shown, find the currents IA, IB and IC. This circuit may look complicated, but it's very simple to solve. Consider this node as node A. The entering currents are 3 amps and 1 amp. The leaving current is IA. Therefore, IA is equal to 3 plus 1, which is 4 amps. Now consider this node as node B. Here the entering current is 4 amp. The leaving currents are IB and 3 amps. Hence, 4 is equal to IB plus 3. So, IB is equal to 1 amp. Now consider this node as node C. Here, the entering currents are IB and IC. The leaving current is 3 amp. So, IB plus IC is equal to 3 amp. We already know IB is 1 amp. So, IC is equal to 2 amps. That's all for today. Bye. See you in my next video.